As Lee John said, I'm going to talk about CrowdStrike. I'm going to talk about a couple of other disasters too. Actually, I think CrowdStrike is probably the least bad of the three. But I'm going to try and convince you that they all have the same cause in common, and I'm going to try and tell you how you can avoid being in the same cycle and having the same problems yourself. A little bit about me. As you've heard, my name is Howell. I care a lot about technology and learning. I self-taught programming at the age of 9. I would say self-teaching is not a great way to learn to program. This is better code than I wrote when I was 9, to be clear. I wrote code. I learned C++ from a book called Learn C++ in 21 Days. Took me more than 21 days, but I got there. I also care a lot about being a good leader. I used to run these events called CTO dinners in London, which actually I think is maybe how I met you the first time, LJ. I used to run them in this exact room in a pub, which is why that is there. I have a podcast, which is kind of selfishly just a way for me to improve as a leader, because if you have a podcast, you get to interview people who are much smarter than you and have much more experience and learn from them, which is useful. A while ago, I realized I didn't fully understand how hardware worked and how the instructions in the CPU translated into zeros and ones running in silicon and copper. So I've started a project to build my own CPU. Hasn't finished yet, but I'm getting there. I'm also very interested in trivia, so I've been on a few quiz shows in the UK. It's me on University Challenge. Thank you for laughing. I assume that's because I look young and beautiful there, as opposed to the withered husk I am now. I've also been learning the saxophone like most of my life, which is another kind of learning. And then a while ago I learned to knit, and I will never make a project this size again in knitting. It took ages, but I'm very proud of it. This talk really combines tech and leadership and learning, which is why I talk so much about learning up front. And those are three things that I care about a lot. I'm going to talk about these 3 companies where terrible things happened. Firstly, the UK's Post Office. I actually have a laser pointer. Look, I can do this. The UK Post Office, this is an ongoing scandal in the UK. If you're not from the UK, you might not have heard about this, but I'll talk more about that. Boeing with their 737 MAX and the problems that they've had, and then CrowdStrike and their Falcon product, which had very well-publicized problems in July of this year. I'm going to talk about the causes, the technical causes behind those things. I'll talk about their common root cause, and I'll talk about how you can avoid the same mistake. I think it's a bit misleading to talk about the idea of a single root cause here, because these 3 problems all ultimately started from a technical source, but that wasn't enough for them to become the disasters that they did. These are socio-technical problems. They have a socio-technical root cause, not just because of technology, but because of the people around it as well, and how the decisions people made and the way that they responded to the situation they were in. Let's start with the Post Office. So the UK Post Office had this project called Horizon. Brief background, the Post Office in the UK has about 10,000 branches, the places you go to buy stamps, to send your parcels, to collect your pension. These businesses are not owned by the Post Office itself. They are local shops, local independent businesses. And to manage all of the complex accounts for this, to make sure that those companies paid the Post Office the right amount every so often, they asked Fujitsu to build this system for them called Horizon. At the time of its rollout in 1999, this was the biggest IT project in Europe, in civilian world, so like not government or military, but it was the biggest IT project of its time. This software had many bugs and flaws, though. A simple example, if you double-click the button to make a sale, it would be entered twice. But actually, it gave you no visual feedback. So a lot of people would click that button 3 times, 4 times, 10 times. If you're buying a single stamp, that doesn't matter. If you're buying something more significant, it quickly adds up. And that's one of many bugs that this software had. Because of the flaws in the system, it would misreport the amounts that were owed by the branches back to the Post Office. It would get them wrong by sometimes tens of thousands of pounds. But the Post Office trusted the system, and they didn't trust the end users who reported problems and said that the figures were wrong. They didn't listen to the developers who knew that there were flaws in the system. And ultimately, about 1,000 people were taken to court. They were taken to court for theft and fraud and other crimes. This is the biggest miscarriage of justice in UK history. It destroyed some people's lives. It made them unwelcome in their hometowns and their communities. And it actually led to some deaths too. This is still ongoing as an inquiry in the UK government. There was a broken system which meant that small businesses were wrongly charged tens of thousands of pounds. The people who knew of the flaws weren't listened to, and they couldn't convince decision makers to fix the problems because ultimately the business had a lot of trust in the software, more than it had trust in the people who are complaining about it. And this is part of the pattern that you're going to see in some of these other cases. Let's talk about Boeing. Boeing as a company has historically had an incredible reputation. If you listen to interviews with past employees, they talk about their pride in working for this kind of giant of American industry. They talk a lot about the psychological safety they had, the culture they had of reporting problems. There's a quote from an old leader of Boeing saying that the one thing that will get you into deep trouble, and I'm paraphrasing here, if you know the quote, you'll know why, the one thing that will get you into very deep trouble is not telling us about problems. You can actually still buy these stickers as well that employees used to wear. If it's not Boeing, I'm not going. That's how proud they were of their reputation for safety. In 1997, Boeing merged with McDonnell Douglas. McDonnell Douglas has a patchier record, particularly their DC-10 plane. They don't have as good a reputation for safety as Boeing. And Harry Stonecipher came from McDonnell Douglas, and he eventually became the CEO of Boeing. And he said this. He said, "When people say I changed the culture of Boeing, that was the intent. So it's run like a business rather than a great engineering firm." With hindsight, I have to wonder, why can't it be both? Isn't it possible to be a great business and a great engineering firm? Employees report being told to ignore problems and not document them. There was a resistance in the company to acknowledge that the problems even existed because the company wanted to believe that the planes were still as great as they had been previously. Then in 2010, Boeing's main rival, Airbus, launched the A320neo. And the A320neo had more efficient engines. The plane could go further on the same amount of fuel. To compete, Boeing wanted a plane of its own with a bigger range. And they knew it would be more appealing if they could avoid retraining pilots. The airlines would want it more if they didn't also have to train their pilots on a new kind of plane. So what they did was take an existing design, the 737, and adapt it. And that was the 737 MAX. The 737 MAX had bigger engines. Because it had larger engines, they didn't quite fit under the wing, so they had to be moved forward on the wing. That meant that the plane had this tendency, while it was going along normally, to just for the nose to come up and the plane to start pointing upwards. To correct this, they added a fix in software, a software system called MCAS, which would detect that, and it would automatically push the plane's nose back down, so it was back to level flight when that happened. To avoid retraining pilots, they had to act like this model of plane was identical to the original 737. They didn't inform the pilots that the MCAS system existed. They left it out of the pilot's manual, and they didn't retrain pilots on the new model. Unfortunately, the MCAS system was flawed software. A single faulty sensor on the plane was enough to trigger it. So planes are normally built with a lot of redundancy, but a single incorrect sensor on the angle of attack detection would be enough to trigger the MCAS system. And it was written, the software, such that it could trigger every 5 seconds. What that meant is if the MCAS system triggered incorrectly in normal level flight, the nose of the plane would be pointing down. It would start a steep descent back towards the ground. If MCAS triggered erroneously, estimates are that pilots had about 10 seconds to respond. If they didn't respond within those 10 seconds, the situation could easily be unrecoverable. And remember, this wasn't in the training manual. The pilots didn't know this system existed. They didn't know that this failure mode was possible. In 2018, MCAS caused Lion Air Flight 610 to crash into the Java Sea. There were 189 people on board who died. The then CEO of Boeing said, Dennis Muilenburg, went on Fox Business and said, look, the bottom line here is that the 737 MAX is safe. They were strongly convinced that the problem must have been the pilots or the airline rather than the plane. 5 months later, in 2019, Ethiopian Airlines Flight 302 crashed again due to the MCAS system. There were 157 people on board that flight, and all of them died. Now, Boeing's initial statement in the aftermath of this tragedy said, among other things, we have full confidence in the safety of the MAX. At least initially, they were still completely convinced that their plane couldn't be the problem. So this is a company that underwent some serious changes. They had a focus on engineering and safety, and they had that reputation, and then they started to be like a business rather than a great engineering firm. They went from a culture of psychological safety to a culture where people were encouraged to overlook problems that they had seen, but they still believed in the safety of their planes, and the results, the consequences of that were obviously terrible. Let's talk about CrowdStrike. Surely the least bad of these three. The CrowdStrike have this product called Falcon. Falcon is software to detect and monitor and respond to threats to your devices. For our purposes, there are really two key things you need to know about the Falcon product. Firstly, on Windows, Falcon has to run with privileged access. Because of the way Windows is built, it has to run inside the kernel, not in user space, which means when there are problems with Falcon, the system panics and is unable to recover because it's inside the kernel. And because it's a security product, it's going to need regular updated threat definitions so that new threats are kind of automatically available for Falcon to detect. July 19th of this year, you probably all remember this, they pushed a broken update. It went out to every device running Falcon. That blue screened roughly 8.5 million devices. Is everyone old enough to remember what blue screening means? I feel like there was a time when everyone ran Windows, and now people are going to be like, but surely you just reboot it. The machines could not even turn on and boot. Even if you rebooted it, it would not get past the boot sequence and load Windows. This caused global disruption. Roughly 5% of global air traffic was grounded. A lot of emergency service lines stopped working and so were unavailable to people in emergencies. A load of health services were disrupted as well. Now, in fairness to them, CrowdStrike have been very public about software flaws and problems with their process that led to this point and what they're doing about them. So, for example, the threat definitions were validated with a regular expression rather than a parser, not great. They had unit tests, but the unit testing only covered the happy paths, didn't cover problem cases. They had manual testing, but it only covered valid data. They had no phased deployment, so once this was rolled out, it was rolled out universally to everyone at the same time. I have to say, I find this somewhat surprising, because this is a $60 billion company. They are doing something very technologically advanced with a mature product. What would surprise me is if there was no one inside CrowdStrike who knew that these things were problems. I haven't seen a whistleblower saying this, but I feel confident that they must have had people saying, we should be using a parser to do this parsing. We should have canaries to test our stuff works before it goes out to everyone. We should have phased deployment rather than it going to everyone simultaneously. And while I haven't seen those quotes, what I can do is look on Glassdoor. So I thought it'd be interesting to look at the last 10 reviews from the engineering function before this date in July, just to get a sense of how people in engineering view the company's culture. And I think on the whole, it's quite a positive picture, right? The overall ratings of 4.1 stars on average, quite a few 5s in there. This is a company where people are happy and like working there. But there are definite suggestions that management is overly strong. The management style is aggressive. It's been described as a boys' club. There's a lack of engineering expertise in middle management. And some people feel that management is pushing too hard on engineers, telling them how to do things, which corners to cut, not just asking them to build, not telling them what needs to be built, but telling them how to build it too. I wonder if you see the same pattern here that I do between these three cases. With the post office, they had so much confidence in their system that they acted like bugs didn't exist, and they ignored people who told them that there were bugs. And ultimately, the consequences were very tragic. With Boeing, the company had a history of great engineering and safety, but they had this MCAS system which had some serious flaws in it. In the meantime, though, the company had shifted away from its focus on great engineering, from its focus on psychological safety, and resisted hearing about problems, but they still had confidence in the products that they built, and ultimately many lives were lost. CrowdStrike has a surprisingly immature process, and the culture seems to involve non-technical people pushing engineers into bad decisions, and many essential services were shut down around the world. I find the idea of systems analysis very useful, and if you haven't read the Dana Meadows book, Thinking in Systems, I would recommend that to you. In systems analysis, we try to capture the different factors in the state of a system and look at the interactions between them. And in each of these companies, ultimately, there were bad outcomes caused by the quality of the product that they produce. That's, in some cases, unsafe planes. In some cases, it's just bad accounting. And in some cases, it's an unstable product that takes down a load of devices. That is essentially determined by how much quality is prioritized. The more we prioritize quality, the higher it will be. That, I think, is pretty obvious. And in each of these cases, the prioritization of quality seems to be being done by non-technical folks. There are technical people with a voice, but they are not the ones prioritizing quality. Now, the thing that I think makes this interesting is to observe that there is a feedback loop here. The non-technical manager will see the outcomes and will decide the prioritization of quality. But they will do so with a negative factor in there. When quality is high, we don't need to prioritize it so much. Things are good. We can focus on other things. When quality is low, well, that's a problem. Now, the priority of quality has to go up. And this is a balancing cycle. This will find its equilibrium level where the quality and the outcomes is enough that it's kind of stable. We don't need to change anything. Things are just right. Why change a system if it isn't yet broken? At the same time as all of this, we have external forces. We have the market, we have commercial pressures, we have the product roadmap, the things that we need to build, which must necessarily take time away from the prioritization of quality, right? That is going to push the equilibrium level of quality down. So the question is, what can we do as a group of technical leaders? How do we prevent this push, this drive to the bottom, and people forgetting about quality? And I would say that's by being the missing bit from this diagram, because the diagram is not complete. As a technical manager, as a technical leader, you also have a perception of quality. You probably have it more directly from the product itself rather than necessarily the outcomes. And hopefully you also have some routes to changing the perception of quality in non-technical people and how quality is prioritized. Hopefully you have that influence. You have the ability to stop this. But what I would say is that at the post office, at Boeing, these people existed. There were technical people who knew that there were quality problems. And I suspect the same is true at CrowdStrike too. And those people weren't able to change things. So then the question becomes, how can you be different? I would say the answer is learning. I think everyone in this room probably started their career learning languages like C++ or JavaScript, and you talked in terms of things like variables and class methods and things like that. And then to be in this room at some point, you learned the languages of management and leadership, and you started talking about like quarterly strategy or budget planning cycle, and you learned how to talk in those terms. I think if you're going to be if you're going to be the solution to this problem, the next thing you do is to learn the languages of influence and finance, to talk in terms of risk mitigation and brand equity and reputational damage instead of in the technical outcomes. And then hopefully you can be this person in this loop, preventing the drive to reduce quality and all of the problems that come with it. In these 3 companies I've talked about, the technical folks weren't able to do that. They didn't succeed in preventing these disasters. But I'm giving this talk in the hope that you can do what they could not. I've used loads of images for this talk. You can find some of them here. I also want to give a massive credit to Nick Means. Nick did an amazing talk about the 737 MAX and applying systems thinking to that. Really recommend watching his talk if you haven't already. I've said already that I'm very passionate about tech leadership and learning. I'm passionate enough that I started a company to do learning better for tech teams, and passionate enough that we sponsor CTO CraftCon. I actually think failure is super important. It is a critical part of learning. We need failure to learn. We need feedback to learn. But ideally, we need to have that failure outside of the learning environment. Most training just shows people the happy path and lets you try and get on with the failure bit by yourself and do it with your production code. We created a training approach which we call micro workshops, which brings the failure, the ability to try new things into the learning session in a sandboxed environment with an expert who gives you feedback, answers questions, and helps you understand how to avoid those failures in your work without system failure. We work in hard skills. We work in more transferable tech skills like, I don't know, test-driven design, test-driven development and API design, but we also work in management and leadership skills too. Come find me and Haley on the stand outside. We would love to talk and see if we can be helpful to you and your team. Thank you very much for listening. Same here.
I think we've definitely got time for 2 questions because mine's second. But the first one, which is a real question, how do you define good or good enough quality?
How do you find good or good enough quality? Well, I think as an engineer, you have a strong sense of the outcomes before they happen in a way. That is an advantage that you have that non-technical people don't. So if you listen to Boeing engineers talking about the problems they've seen, a lot of them talk about the fact that they wouldn't fly Boeing nowadays. They have seen too many things. They've seen too many shortcuts, right? Those are people who are very close to the production process, who know the downstream effects, which are much easier for technical folks to perceive than non-technical folks. And so ultimately, I think as technical people, you know what the outcomes will be before they happen. You just have to translate that into the right language for non-technical folks. I don't think there is an objective definition, because if you're writing the software to control an aeroplane, there should be a different standard for quality than if you're writing, I don't know, if you're a 2-person team coming up with a new social media application. The way you think about quality should be entirely different, but you probably know what good enough means.
We'll go to the next real question. How can you change a top-down culture?
How can you change it? I've just seen your question, Lee John.
I didn't ask it.
We will need to talk more about that. I think I already answered that as well. The problem was that someone was trying to make SQL a language that it's not. They were like, "Oh, SQL isn't an imperative language," and it's like, well,
we've got an hour.
If you're going to change it, if you're going to judge it by that, how can you change a top-down culture? If the culture is already top-down, I think you need to convince the people at the top either to change or the benefits of change. So again, I would talk in terms of, talk in other people's language. So if you're working with someone who's very top-down in their thinking, say, well, look, our ability to respond to the environment, our ability to respond to what we're learning is really hampered because every time we have to bring decisions to you, the outcome is the same, but it takes us a month to make that decision, whereas we could be responding in a day if we were able to decide those things independently without wasting your time on it. So assuming that you are working in a top-down culture and not able to change it yourself, you need to advocate to the people, who do make that decision in terms of the things that they care about. We actually have an entire module on influencing and understanding the kind of things that other people care about and translating things to their language. So that's a 90-minute module. I am condensing it into a 1-minute answer because obviously we need to focus on the.
You've got a lot to go through. Yeah. No, thanks for your time, Hal. Thanks for letting me troll you on stage. And just give a big round of applause there.
Thanks, LJ. Appreciate it.